Before we get started here, I was going to explain a couple of things in our setup here. This little cardboard box right up here on top of the signal generator is a special circuit that we set up. We can just pan over on the inside of the box. You can see an array of transistors and what's called isolation circuits, which allow us to switch each transistor separately so that they do not interfere with one another. Looking down in here, we can kind of pan the way the electronics is set up. This setup requires that we use a signal generator, seen here in the video. In our signal generator, I'll pan in here a little bit, is sending a signal up here to the box, here and here. We have an array of transistors going across the top and across the bottom, but right now we're just using two sets of transistors to where our input signal comes in here, it comes out here, and then loops back into this transistor, and then it outputs from this wire, following it all the way down and over here. Now I'm going to set up my tripod. What we have done is that we've set up an unusual event, best way to describe it. We have a small wound inductor which I custom built here, and we're going to send a signal into this inductor, and through an unusual transmission of frequency and the inductor value, we're going to come over here, and up here at the top of this electrostatic meter, which is rated at a peak of measuring up to 1500 volts, we have a capacitor which is tied across the two terminals. We have a lead coming from each side of our inductor to the capacitor, and down here at the bottom I have a AA battery rated at 1.5 volts here. What we will do next is, let's come up here and look at our meter. We're going to take the 1.5 volt battery and we're going to connect it to through the transistor array, and at 1.5 volts we're going to resonate the inductor, and when we do, we are charging our capacitor to such a voltage that it literally goes off the meter. It's slowly discharging through the circuit. Now I'm going to do it again. Disconnect, it discharges. We're using 1.5 volts. It's slowly discharging. And I'm going to connect it again. And as you can see, it goes off the scale of the meter. We have it set up so that we have a very high resistance resistor, which slowly allows the meter to discharge. Let me back out just a little bit. Let's connect it to the wire again. 1.5 volts. over 1500 volts. So by resonating the signal, we can take an infinitesimal amount of voltage, in this case 1.5 volts, and essentially multiply the voltage over 100-fold. Actually 1,000. It'd be right at 1,000 to 1. Anyway, this concludes our very short demonstration.